Okay, so here in this question, okay, a long tapering pipe of diameter 1 meter from the higher end, okay, to 0.5 meter at the lower end. Its slope is given 1 in 100 and the length of the pipe is 300 meter. The pressure at the higher end is given, okay, we'll see later. So we have to find the pressure at the lower end. And the quantity of water here is given 5,400 liters per minute. So the given length of the pipe L is 300 meter. Okay, right here 300 meter. Diameter of the pipe at the lower end is 0.5 meter. So right here 0.5 meter. Therefore, area A1 as section 1, it's pi by 4 into T1 square. Okay, you calculate, you will get in meter square. Similarly, diameter of the pipe at the higher end, okay, at the higher end, diameter is 1 meter, so you write here 1 meter. Area A2 pi by 4 D2 square is equal to how much? Calculate here, right? Now, the height of the lower end above datum. Okay, so you see this datum line is coinciding here with the cross section at section 1 of the pipe. Okay, so Z1 is 0. There is no height. The datum line up to the lower section, right? Now height of the higher end above datum. Okay, above the datum line, the height at this higher end, okay, this is not given the height. However, the slope is given 1 in 100 and the length of the pipe is 300. So how will we calculate Z2? Z2 is 1 by 100, okay, the slope 1 in 100 into its length, that is 300 meter. So you calculate here, you write it in meter. Now the quantity of water flowing in this pipe, okay, it's 5,400 liters per minute. You change it into second. Okay, so you have to write here 5,400 divided by 60. Okay, it's changed to second. You calculate, you will get some value here, which is in liters per second. Now from liters per second, you change it to meter cube per second, which I've given you in the notes. Okay, the conversion from liter to meter cube per second. Okay, you calculate and you get it here. Okay, so now the pressure at the higher end, if you remember the figure at this higher end, is given 0.7 kg per centimeter square. We'll convert into meter square. Okay, it's 0.7 into 10 to the power 4 kg per meter square. Now we have to find the pressure at the lower end. So let us say that P1 be the pressure at the lower end. Now we know from the equation of continuity, Q is equal to A into V, area into velocity, discharge. Okay, so the velocity at section 1, okay, at this section 1 at the lower end of the figure, you check, V1 is Q by A1. A1 you have calculated, okay, from the previous steps. So you put the value of Q and A1, you will get the velocity at section 1. Similarly, the velocity at section 2, you get Q divided by A2. Okay, put the value of Q, A2 and Q, you will get V2. Now, from Bernoulli's equation, we know Z1 plus V1 squared divided by 2G plus P1 divided by W equal to Z2 plus B2 squared by 2G plus P2 divided by W. Here, okay, since the unit is in meter, okay, so the small w is 1000 kg per meter cube and g you take 9.81 meter per second square. Now putting all the values of Z1 0, V1 you find it out, put it here, 2 into G 9.81, then P1, okay, we have to find P1 divided by 1000 equal to Z2, okay, after calculation from the previous step you put it here, V2, okay, you'll get from here, square of it, you keep it here, 2G same 2 into 9.81 plus P2, okay, this is given, put it here, that is 0.7 into 10 to the power 4 divided by 1000, okay. After calculating all these, you find out P1, which will be in kg per meter square. You convert it into kg per centimeter square. Okay, so this is the value of P1 which you have to find out.